Okay, hello everyone. Welcome back to a new episode of. Oh, it says live 0 seconds? Okay, let's try again. Hello everyone, and welcome back to a new episode of Advent of Code 2017. We're doing today's stream live. It claims I have one viewer. Is it me? Participants. I don't know. It's a mystery. It's been forever since I did a live stream. I did several of them last year, but this year we're doing a special event of a sort wherein I'm going to do this one live starting at 9, specifically because my friend Will Morgan, who has been recording his episode, streaming actually all of his solutions and been competing to get onto the leaderboard, wanted to call in and chat. I don't know exactly how that is going to work. My best guess is he's going to call me when he's done solving the puzzle, which will be well before we're done. So, I don't know. Hopefully it'll work out. If not, like, hey, you guys can watch it live, whatever. No, no, like, big thing compared to seeing it recorded. And of course, it's getting recorded as well. It'll be up on the channel as a recording when we are done here. But as I did last year, today I started about 5 minutes early to give people time to settle in, maybe say hello. Get out of here. We don't care about that. I started trying out Oxygen Not Included, the game. And I had a search tab out about like how the heck does everything in this dang game work. I'm not really planning to upload that to the channel, but I suppose one never knows. At any rate, we're not uploading it right away, so I was just playing, not recording. Boy, it is like 5 minutes is a longer time than you think, you know? Oh, and by the way, something which hopefully will not be material, but that I would like to warn you about, is that I am on call at work today, this evening, so there is some possibility that my pager will go off sometime tonight, and I'll have to go away to look at it, because that is like something I actually, as part of my job responsibilities, to occasionally be on call. But it's been a quiet week. My bet is it won't be a problem. I'm just apologizing ahead of time for some loud ringing noise that you might hear, and then me saying, sorry, gotta go. Kind of ashamed to do this live thing with Will on a night that I'm on call, but I'm bad at planning, so there you go. All right, we are almost there. 10 seconds. It's like watching the ball fall on New Year's Eve, sort of. I'm going to refresh it. Yeah, didn't make a difference. But we get to watch this cool thing, huh? All right, day 13. Here we go. Day 13, packet scanners. You need to cross a vast firewall. The firewall consists of several layers, each with a security scanner that moves back and forth across the layer. To succeed, you must not be detected by a scanner. Okay. By studying the firewall briefly, you are able to record in your puzzle input the depth of each layer and the range of the scanning area for the scanner within it, written as depth:range. Okay. A layer at depth 0. Each layer has a thickness of exactly 1. A layer at depth 0 begins inside the firewall. A layer at depth 1 would start immediately after that. Okay. So range is thickness, sort of, right? Okay, so they've got a diagram here. There's a layer at depth 0, which is 3 things long, at 1, which is 2 things long. Okay, so these aren't stacked up exactly. Oh, I see. This is a periodicity kind of thing, like the one last year with, like, dropping marbles. Within each layer, a security scanner moves back and forth within its range. Each security scanner starts at the top and moves down until it reaches the bottom, then moves up until it reaches the top and repeats. A security scanner takes 1 picosecond, which is just like our generic unit of time, to move 1 step. Drawing scanners, yes, so it goes like this, okay, alright, we understand all of this. Your plan is to hitch a ride on a packet about to move through the firewall. The packet will travel along the top of each layer, and it moves at 1 layer per picosecond. Yeah, sure. Each picosecond, the packet moves 1 layer forward. Its first move taking it into layer 0, and then the scanners move 1 step. If there is a scanner at the top of the layer as your packet enters it, you're caught, but not if the scanner moves on top of you after you enter. If you were to do this in the configuration above, your passage would look like, yeah, wait, marking current position with, oh, geez, I can barely see these, okay. I mean, they look very similar to the square brackets anyway. So 0, we're here. Beginning of 0, end of 0 is what they're showing me. Beginning of 1, end of 1. 2, nothing scans us. 3, nothing scans us. Beginning of 4, end of 4. Beginning of 5, no one cares. Beginning of 6, oh no, we walked into it and we got zapped at layer 0 and 6. The severity... Oh, interesting. Okay, this is easier. Whew. I thought they were going to ask us, when should you leave to not get caught at all? And that'll probably be part 2. But part 1 is just making no decisions. Can you accurately simulate the problem? Right, supposing that you leave right away, how many, where do you get caught, basically? Okay, so this seems relatively straightforward. We're going to read the file into a list of these definitions, and we'll have a function that I guess we just want a function that, given a range and a current time unit, tells you whether you get caught at that time unit in a scanner of that range. Which is pretty simple, right? Like there's one of size 1 just goes down, up, It doesn't like take a second to turn around, right? Picosecond 0, it's here, and then at the end it's here. 1, it goes from here to here. Okay, sure. And then we'll just sum that over the list of all of the scanners multiplied by the thing. Okay. Seems relatively straightforward. Let's get started. Okay, so out of curiosity, we have 84 depth is our, interestingly, only even numbers, except for 1. Wonder why that is. But okay, and like the scanner sizes, you know, go from like 2 to 20, 2 to 18. The 3 at the beginning is interesting. I guess there are some odd numbers. There's a 5 here. Okay. Alright, so let's get started by defining some types. Data, firewall is a firewall of... Oh, by the way, if you're watching this live, you may be... well, I have a few things to say to you. One is, well, hello, welcome, what a surprise. Another is I probably will not be paying any attention at all to the chat. Sorry, I'm just not very good at doing that. That's why I do this on YouTube instead of, say, Twitch. But who knows, maybe I'll get lucky and I'll notice. And the other is that this is day 13, and I haven't yet uploaded the solution to part 12. I did solve 12, but I haven't had time to go through and explain it yet, and so I'll do that probably later tonight. Anyway, back to this puzzle. We have a firewall, which is just a... I mean, it's range is an int. Actually, range and layer are both ints. And to be honest, we'll probably never use these accessor functions, but at least now I can remember which is which when I pattern match against it. And I think the main function that we will want is hot. Yeah, I guess. So do we care? We don't care what the layer a firewall is at in order to know if it catches us, just that the layer is a time unit. So if we leave it 0, layer and current time are the same, but I'd like to be flexible about the possibility of leaving at a time other than 0. And what we actually care about is the time, not the layer it's at. So I think I will also define type time equals int as well, to be clear that what we're taking, actually, type, oh my god, get out of here, Emacs, I don't need your help. Document type layer equals int, I guess type range equals int, and then like we can sort of just get rid of these and say it's a layer and a range. Time is an int as well. So 3 different names for ints that will let us make our function signatures more clear about what the various ints we're receiving mean. So cot is a function that takes a... I guess it doesn't much matter what order these arguments are in. Of course it doesn't matter semantically, but as far as the compiler is concerned, as long as we're consistent. But sometimes there are orders that make the function more convenient to work with, and in this case I don't think either one helps much. So this is just a function taking a range and a time and producing a bool. Right. And so given a range, at what times is the firewall at the top of its range, right? So for 2, it's at the top of its range if the time is even, right? It goes up and then down. But for 3, it's not the case, right? It's at time 0. Here, let's see if I can maybe draw something. So there's a 3 here, right? At 0, of course, everything is caught. And at 1, it's not. At 2, it's still not. At 3, it's still not. And then at 4, it is again. So it's sort of like you take the range, multiply it by 2, and subtract 1, and that's the modulo you're working with, I think. 1, 0, 1, 2, 3, 4, 5, 6. Well, that didn't quite work, did it? 0, 1, 2, 3, 4, 5. So it's here at the beginning of 0, right? Okay. So probably you subtract 2, or alternatively you take the range, subtract 1, and then multiply by 2. That works for... Yeah, okay. That's the modulo we're working in. All right. So cot then, cot of R and T is just that T mod R minus 1 times 2 equals 0. So, oops, wrong. So if I say cot well, let's say map cot of 4 on like 0 to 10. Do I have to load? Yeah, so it's caught at time 0, and then this is a little bit hard to read, isn't it? There we go. And then also at time 6, which I think is what we said about the 4 thing, right? 0, 1, 2, 3, 4, 5, 6. Yes, okay, great. So that looks correct to me. Go away, REPL. There we go. Okay, so that's the main function that we want. We'll define additionally a function called cost, which takes a firewall and a time, I guess. Cost of firewall layer range equals no, not equals, t equals bool, I guess, bool 0 of cot range t layer. Oh, hang on, no. What's the formula for how much the thing costs? It's depth multiplied by its range. Okay. So remember, oh, we have to import that. Oh, it needs a result. Jeez. Now, why are we upset about all of these functions? Oh, of course. Whoop, there we go. So remember, bool is the thing that does pattern matching on booleans for you, and you know what? This would just be better if I were to say, if I were to write this out by hand, where if you are caught, then it's equal to this, and otherwise is 0. There you go. We could, bool does that, and I think bool is kind of cool, but this is clearly more readable. Okay. And so now let's have like a parse function, probably. Parse is a function that takes, what's our input look like? Okay. So some number of digits, a colon, a space. Fine. Parse, I guess, then will be a function from string to firewall. Parse of s equals let. We need break again, don't we? Or span or something. I always forget how they work. Span equals colon of 1x. Okay, so we want break, not span. There we go. Equals let layer layer comma a colon cons to a space cons to range equal break equal colon of s in firewall layer range. Oh, whoops. We need to read both of these. Is there a more clever way to do that than just calling read on them? I don't think so. You could do something clever with like a list and the list applicative or something like that, but it would not be more readable than this. Okay, map parse over all the lines we got. Very good. Fine, and so now I think part 1 is a function from list of firewall to int. Part 1 of FWs equals sum of map. No, not map. Well, actually, yeah, because the firewall's range or layer is going to also be the time in this case. So, in fact, let's write sum of cost FW T where FW as firewall cost, yeah, it takes a firewall and a time. We'll just let the time be the same as the layer, I guess. We'll call it layer. Firewall layer range in FWs where cot layer. No, range layer. Alright, now let's like that maybe? I don't know. I don't know how you're supposed to indent list comprehensions. I hate them. That's why I always use do instead. But like, good news, this type checks, right? So let's see what happens. Run GHC. An answer. Sure, why not? That's the right answer. You are 1 gold star closer. Rank 298. No, I want to go back to the day 13. Okay, so now it's going to ask us how to not get caught, right? Yeah. Yeah, so what is the time you should leave to not get caught? Fine. So this is where it gets to be like the thing from last year about periodicity in like that big old gearbox machine thing. Basically, each scanner represents a constraint on what time we can leave, where that constraint is of the form anything that is not equal to mod foo of, you know, equal to 0 mod, equal to n mod m, basically. And I don't actually know a clever way to do this test. And actually, we only have a very small number of inputs, and like each scanner doesn't catch you that often, and so I feel as though we can maybe just brute force this. I don't like that idea so much, but like last year's thing, it has to be equal to n mod m rather than not equal to n mod m. And so it was a much stricter constraint, and brute forcing seemed a lot less promising. And indeed, the answer was quite large. Here, I suspect the answer might not be so large, and we could brute force it reasonably well. And I don't know how we would do it otherwise. I'm sure there is a clever way. I assume it's asking us the fewest number. Yeah, so you have to find the best answer. Oh, by the way, do you guys want to like see this window? Sure, why not? All right, as predicted, nobody in the chat noticed, so it was perfect. That's because no one's in the chat, of course. So I think that part 2 is simply the following. Here's a list of firewalls, and returns an int. And part 2 of firewalls is going to use part 1. It's basically going to be minimum of start, where start is drawn from the list of integers beginning at 0, such that part 1 of FWs, no, I can't quite use part 1, can we? Okay, we'll just give part 1 another argument, int, here feels about right, I guess, offset, we actually just want layer here, so this now needs to change to part 1 of 0. Why does this not compile? Oh. Well. Wait, I'm fixing the wrong type signature. First of all, part 1 needs its arguments reversed is the main thing there. Now main doesn't type check because we didn't finish writing part 2. That's fine. Such that part 1 of start and FWs equals 0. Oh, and now these arguments are flipped. Fine. Okay. And I'm going to run this compiled, not interpreted, so that if it does turn out that brute forcing is viable, it'll at least be done a bit quicker. But already it is taking some time, which makes me wonder, is there some cleverer solution? Is this like... You can sort of do like the prime algorithm of the sieve of what's his name? Arrest, I can't pronounce it, but like that Greek guy. I think. I think that you could do that because we're basically trying to find a prime number in a way, except that we don't want it to be not divisible by anything. We want it to be, rather than being equal to 0 mod something, which is what primes are all about. You find all of the numbers that have factors, i.e. that are equal to 0 mod some other number. And it seems to me that we could basically just do the same thing, but erase those numbers which are equal to... No, because the numbers that you rule out are still valid starting times, right? So I don't think you can use that algorithm exactly. So, what we could do, I suppose, is shrink the search space a bit, I think. Or make it cheaper to search a particular to try to find an answer for a particular offset. There must be, I would think, maybe I'm wrong. There may be though, some number of firewalls which are sort of redundant, where one subsumes the other. Say two different firewalls that both that both have exactly the same n and m in the not equal to n mod m, or where like one of them is like, oh, you can't be equal to 0 mod 4, and another one's like, well, you can't even be equal to 0 mod 2, so forget about those stupid 4s. In that way, we could perhaps pare down the list of firewalls that we're working with and make it faster to test things. But I'm still not sure that that's promising. We could stop doing so much dumb division, I guess. Oh, killed. We ran out of memory. How exciting. That's interesting. Why would that have happened? I don't actually see any cases where we're building up a bunch of memory. Oh my god, I'm calling minimum. Oh, what an idiot. Head. We want the first thing where the cost is equal to 0. Ugh. Alright, this will be fast, I bet. I'm just dumb. Yes, it says 1, which I don't believe for a second. 1. I mean, I guess it could be right. I'll type in a 1. That's not the right answer. Okay, fair enough. You got me. So our part 1 function must be... I must not have taken the offset into account properly. I mean, I suppose our part 2 could be wrong, but it seems pretty simple now that I fixed the obvious gigantic bug. Part 1 of start and the list of firewalls is equal to 0. In part 1, we add up the cost of... Wait, cost? Why does it take a time? It shouldn't take a time, it should take a layer. I tricked myself by putting an expressive type here, and I believed myself, but I was totally wrong. Right? Oh, wait. Cost already calls caught. So this whole thing should just be sum of... We shouldn't have this cost here at all. Cost takes a firewall and layer plus offset. Cost of a firewall and the current time when we get there is layer plus offset. Okay. Oh, that's a better number. I like that number. That's still wrong. Okay. The cost of being caught by that firewall at the firewall's layer plus the starting offset. And then we call part 1 start. Alright, am I maybe off by 1, misunderstanding exactly what they're saying here? Fewest number of picoseconds. Delay 10. No, I think I understand that correctly. So we choose a start time, which is at least as large as 0. And if calling part 1 at that start time with the list of firewalls produces 0, then that's an answer. Is that maybe a bad assumption? The cost of being caught... Ah, wait a minute. Maybe we're ignoring firewall number 0 because we're multiplying by 0 somewhere. What's the formula again? The severity of getting caught is equal to its depth. Yeah, I see. So the trick is, I think, we just got caught at firewall depth 0, which we said, oh, that's fine, the cost is nothing. But this one isn't concerned about cost, it's about whether you get caught at all, even if it costs 0. So I think we need to be a little bit more careful here, and just maybe rewrite part 1's thing by hand. Start in this, we'll write a times caught, or alarms, sure, is a function from int and list of firewall to list of firewall. Alarms of offset and a list of firewalls is equal to firewall for this, well, actually, w where, and given that caught of range and layer plus offset. There we go. And now we can just say part 1 of offset FWs is we can remove this time argument from cost, I guess, and just say caught range like so. In fact, just that. And then cost of sum.map cost over alarms offset like so. So first of all, does this still get us a correct answer for part 1? Yes. Doesn't fix our part 2 because we didn't fix that yet, but that's fine. Where null of alarms start firewalls. Okay. Okay, that's much better. It's a much larger number, which seems reasonable. We were ignoring the first firewall, basically. God damn it, you guys didn't see any of that. Well, okay, it was the right answer. We're rank 266. I'm never going to get the hang of these multiple windows. What did I do while you guys weren't watching? Good question. I don't remember when I left you guys behind. But basically... Actually, I don't see Will on Skype. I'm going to send him a quick email to make sure that he is indeed coming, which was part of the point of this thing. And then I'll get back to you guys. Okay, great. So what did we do? The problem was that we were computing the cost of being caught by the 0th firewall as being nothing, which was true, but we didn't care about the cost. We had to avoid getting caught anyway. So I removed the time argument from cost, and it now just takes a firewall. And therefore, I defined a different function used by both part 1 and part 2, which just for a given start time computes. Oh, also, part 1 doesn't need this extra argument anymore. need to fix up this to not call name anymore. So now we have this alarms function which just computes all of the times you are caught given a start time. And part 1 just adds up the cost of all such alarms given a start time of 0. Part 2 says, well, try all the start times there are, and only if it is the case that the list of alarms from that time is null, i.e. empty, then return start and take the first such value. And there you go. That got us our answer. Seems pretty reasonable. I'm a little bit bummed that I didn't think of a more elegant approach, but this seems fine, I guess. Day 13, part 2. And how did that get diff end up looking anyway? We changed how cost works, simplified that, which I agree with. I think this is a better implementation now. We should not have tangled up together the notion of being caught with the notion of a cost. It was convenient for part 1, but not a great idea. And it would have been convenient for part 2 if being caught at range 0 didn't matter. But I think this is still a better model. We left parse alone, we added this new alarms function, and we simplified part 1 greatly by using that new alarms function, which is nice. And then we wrote part 2, relatively straightforward. Hey everyone, sorry for this sudden cut to probably not the screen you were just looking at. It turns out I had some technical difficulties, i.e. like, I correctly unmuted my desktop audio, but like I guess I was recording the wrong audio, like what was coming out of my speakers instead of out of my headphones or something. And so we did end up getting Will on the stream, and we chatted for a bit, but he was muted the whole time. No one could hear him but me, and so I just sound like a complete doofus talking to myself. So I'm editing that part out. Anyway, like, go check out his channel if you would like to see someone else doing Advent of Code. It's a shame that we didn't get the recording properly put together. When I say we, of course, it's just me, that I messed it up. Oh well, not a huge deal. Hopefully you guys still enjoyed the solution to the problem and on a bit of a quicker time scale than usual. Anyway, that's all for this post-it. Not post-it. What do you say? Postscript? This postscript? Yeah, PS. Thanks for watching, and I'll see you next time.